right, thanks everyone. So yeah, my name is Bryan Hughes. I work for Microsoft as a technical evangelist. I'm also really involved in the Node.js project. I'm a member of both the technical steering committee and I am the chairperson of the community committee. And today we're going to talk about TypeScript. TypeScript is something that I've personally been using for a little over a year now. So I'm pretty familiar with it, but I'm also not like a super old timer. I don't work on TypeScript itself. So I kind of fit this sort of intermediate level of developer in this. And so we're going to talk about how to use it specifically with Node.js. So first we're going to start off with what is TypeScript itself. You might have heard about it. You especially might have heard about it from Angular 2, which uses TypeScript. And so yeah, we'll talk about it a bit. So TypeScript is a language. It's a programming language. It is a compiled to JavaScript language. So you can write your code in TypeScript, run it through the compiler, and it will output regular JavaScript. Much like if you're using Babel to compile ES6 or ES7, or if you used CoffeeScript back in the day. I didn't. I wasn't a CoffeeScript fan myself. But TypeScript is really basically just JavaScript with a little bit of extra stuff on top of it. The big thing that TypeScript adds is static typing. If you haven't heard this phrase before, what static typing is it means whenever you create a variable, that variable gets assigned a type. So it means this is going to be a number or a string or an object or something like that. And once it has that type is never allowed to change. If you ever try to change the type of it, you'll actually get a compile error out of it. This is opposed to JavaScript where you can change the type all day long. You can do var x equals 10, and then you could do x equals the string foo, and that's perfectly fine in JavaScript. But in TypeScript, that's not allowed. Excuse me. And so in TypeScript, we then use this to build up a bunch of higher level constructs that really help to architect your code. We add classes and interfaces. There's a module system that TypeScript ships with. And then, yeah, as I said, it compiles back to just regular old vanilla JavaScript. So this is a little bit of what it looks like, just a little bit of sample code written in TypeScript. This is very, very simple. All it does is it takes two variables, a first and last, and combines them together as if it were named into a single string. And we're creating a couple of variables. You can see we have this const first name, and we set that equal to Philip, a string. We have a little bit of extra stuff here. Notice how there's a semicolon right after the variable name, and then we have this word string. And so that semicolon followed by this word string, that's the type. This is where we say this variable, first name, is a string and not anything else. And there's a similar thing up in the function. If you look at the function parameters for first and last, we once again have that semicolon followed by the type. And then at the end of our function, after our closing parentheses, we have another semicolon and type. And that indicates the return type of the function. So in this case, it takes in two strings and returns a string. So you can write this code. It runs perfectly fine, just like we would expect. But if we passed in, say, the number 10 as instead of first name, that would actually be a compile time error. The compiler would give you an error before you even go to run your code, which is actually pretty awesome. And we'll talk about why that's a good thing later on. So building on top of that, there's then the concept of interfaces in TypeScript. And an interface, this is very similar to interfaces in C# and Java, if you happen to use those. If not, you can think of an interface like a contract, and a contract for objects specifically. And we create an interface, and then we can create an object, and we say this object is going to conform to this interface. So in this case, we created an object called fry. We say it conforms to the iPerson interface. And then it will actually check to make sure that this object we created has all of the properties specified in the interface. And we say, so in the interface, we say we have these three properties, and we say they have this type. So if we left off one of the properties in the object fry, we would actually get a compile time error. Or likewise, if we gave it the wrong type, that's also a compile time error. So whenever we're creating these object literals all around in JavaScript or in TypeScript, it will actually check to make sure we don't have any typos in property names and things like that. And this is all a compile time too, which is kind of awesome. Building on top of interfaces is the concept of classes. These are really similar to classes in ES6 and ES7, if you've used those. We just have a couple of extra things on top of it. The first is that a class can implement an interface. This is actually really handy if you have different types of classes that all have maybe say the same base properties. And you want to just make sure that all of these different class types conform to this interface construct. And you can pass the interface around and use it in different files. But now I mentioned earlier about how whenever you're creating an object that conforms to an interface, it has to have exactly that number of properties. It's actually not quite true with classes. Classes are a bit of an exception. They have to contain everything that's in that interface, but they can also have a few extra things on top of that. So in this class, we have an interface called ship, and it specifies both a property called name, that is a string, and then a property called takeoff, which is a function that doesn't return a value. Now, in our implementation for the class, you can see there's actually 3 properties on it, not 2. We have this extra one called ship name. And this is totally valid. And this is actually really useful in classes. Because with the class, we have this sort of external contract that we want people using that class to use. But then we also have internal variables for storing state and things like that. And we don't want people to access those. Historically in JavaScript, we would put an underscore in those method names. If you're using ES6, you would use symbols. And this is what it looks like in TypeScript. Now, you notice in front of every single property, we have this public and private thing. This is another concept that if you come from the C++, Java, C# world, it's going to be right at home. It works exactly the same way as those languages. And if you're not familiar with those languages, what these little modifiers do is they basically tell you who can access it. If a property is labeled as private, then only that class can access that property. And in fact, under the hood, this is converted to using ECMAScript 6 symbols. But then if it's public, it acts like just a regular old JavaScript object or class property, and anyone can call it and access it. I mentioned modules as well. Now, there's actually a little thing about this. This is actually not a TypeScript thing. This is actually just straight up ES6 modules. It is exactly the same as the ES6 module spec, with one very slight addition to it. And the addition is that you can also import an interface. Because an interface is not actually an object in memory, so it's not something that's there at runtime, but it is there at compile time. So we have this ability to import an interface from a different file. And this is really, really handy because we can put our contract in one common place, and then the rest of your code can use it everywhere. And so here we have the same code we had on the previous slide, except that that interface is in a different file. And this is basically these things right here are the core concept in TypeScript. There's a whole bunch of other things that you can do with it. But all of those other things basically build off of these core things that I just showed you. And so if you want to learn more, this is a good chance to go to the website and check it out. So okay, so these things are pretty cool. If you worked with statically typed languages, you might have an idea of why these are useful. But coming from JavaScript, it may not be immediately obvious to you why these are useful and why this helps to create better applications. So let's talk about that. The big thing is type safety, as it's called. So with type safety, whenever we're creating these static types, we have certain guarantees of what a variable is. We know that it's a string, and if it's a string, we know it has certain methods on it you can access, toLocale string, concat, and various other things like that. And so we know exactly what all of these variables are and what you can access on it, and more importantly, we know what you cannot access on it. So let's say, for example, you have an object, and this is something we've all done if you've written JavaScript for any amount of time. You have an object with some properties, you're writing some code that's referencing that property, and you have a typo. You left off a letter at the very end or something like that. You, of course, don't notice it, and then you go to run your code. If you're lucky, you'll get an exception and notice it right away. And then if you're unlucky, you won't actually notice that there's a real problem. There might just be a little bit of weird, funky behavior in a different part of your app. And so this is really hard. It's actually kind of difficult to catch typos in JavaScript. You have to do actual testing of your application. But in TypeScript, because we have guarantees of what these types are, this is caught by the compiler immediately. And you get an error before you even go to run your code. So it surfaces errors much, much, much faster. Related to that is refactoring mistakes. If you've ever wanted to go and rename a property on a class that's defined in one file and is used all throughout your app in JavaScript, this is kind of difficult. Usually you have to go and grep your code base and rename everyone manually, and you hope you caught them all. And you especially hope you aren't doing anything really weird with accessing properties, like maybe taking the name, splitting into 2 strings and adding together or something weird like that. So refactoring is tricky in vanilla JavaScript, but in TypeScript, because we have these guarantees on types, we can do it with complete confidence that when we do the refactor that we did it correctly. We don't even have to run our code to test it. So an example of what that looks like, this is a screenshot from Visual Studio Code. For those of you who aren't aware, Visual Studio Code is a lightweight editor that we created at Microsoft. It's based on Electron Shell, so it's really similar to Atom. It's like really lightweight, cross-platform, and all of those great things. Yeah, I love that editor, and personally, I'm actually not a big fan of Visual Studio. Personal preference kind of thing. Inside of a Visual Studio Code, and I think in a couple of the other editors, you can actually just right-click on a variable and go rename, and you enter in your new name. You can see in that first screenshot where we're entering that new name. And then the Visual Studio Code, because we have these guarantees on types again, will actually find every single instance in your entire application where that property exists and rename it all for you. And we have 100% guarantees that it was done correctly too. So yeah, instead of doing this whole manual process, you're going to grep your code base and test. This is now like a 5-second operation.
So what do you use to compile the TypeScript? Is it vendor specific to Microsoft and Visual Studio?
We'll get to that in a bit. There's a whole section on build pipeline a little bit later. So ideal use cases. TypeScript is great for a lot of things. I use it in pretty much all of my personal projects these days. But there are a couple of specific use cases where it like really, really excels. The first one is if you have a large team. If you have like 20, 30 people working on a single code base, let's say you have a big mono repo, the chance for like stepping on each other's toes tends to increase quite a bit. Especially if one person's doing a refactor over here and another person's doing a refactor over here, and they reference the same object, that can get kind of tricky. Even as good as Git is on diffing, sometimes it's still not particularly great for this kind of thing. And so like TypeScript, because it gives a lot more guarantees on it, it has this like deep knowledge of your code. It makes this kind of like administration and sharing code and things like that a lot easier. And very similarly, TypeScript is also really great for large projects, especially once again in the mono repo case. And there are some reasons you might want to do a mono repo. That's a different talk though for a different day. But like so you have this large code base and you have these classes and objects being used all across your code base. Then can get really even harder to maintain. Refactoring gets quite a bit harder as the size of your code base scales, at least in vanilla JavaScript. But once again in TypeScript, because we have these like guarantees on type safety, the cost of refactoring as your code base grows actually remains constant instead of increasing linearly like it does in JavaScript. And another one that I actually don't see this one talked about as much, but TypeScript is really, really great for people who are coming from statically typed languages. A lot of times we'll have a product that wants to move over to using Node.js, but they have all these developers who created the previous backend in say Java or ASP.NET or something like that. And so they have these skills that are based in these statically typed languages. And switching from one framework to another is a pretty big challenge just in general. Even if it's within the same language. Switching from Express to Sales incurs a certain amount of cost. But if you're having to learn a new language, it's even harder. And if you're switching language paradigms, it's even harder still. And so TypeScript is really great in that it can soften the blow for people moving to Node from these other frameworks. All right, so this whole time I'm talking about types, static types, and things like that. So I want to talk a little bit more about the type system within TypeScript. The biggest thing to understand about TypeScript is that it's really just JavaScript with a little bit of extra stuff on top of that. All of the TypeScript team, they actually really, really love JavaScript. They didn't set out to create this thing because they hated JavaScript or were forced to use it. It's like, they're like, oh, I love this language. This is awesome. I just wish it had this one little extra thing. And so you can see this in all the design decisions. And probably the most prominent of which is that all of the types in TypeScript are native JavaScript types. So there are 7 fundamental types in JavaScript and TypeScript as well. And that is undefined, number, string, boolean, object, function, and symbol. Symbol's a newer type. It was added in ES6, but it is a native JavaScript type. And it's the exact same thing in TypeScript. Those are all the types you have. There is no like int or double or any of these other types that you see in other languages. They decided we're not going to do that. This is just JavaScript types. And same thing with classes. Classes inside of TypeScript are just standard JavaScript prototypal classes. It's just a little bit of syntactic sugar around classes is all it is. It's actually very similar to the ES6 classes as well. If you've used ES6 classes, they're also just a little bit of syntactic sugar on top of regular old prototypes. The other thing about types in TypeScript is that they are actually opt-in. You don't have to use types if you don't want to. Now, if you don't use types, you don't get all this type checking, but it is nonetheless opt-in. And what this really means is that vanilla JavaScript, just regular JavaScript, is actually valid TypeScript. This is one of those big lessons learned from the CoffeeScript days, where if you wanted to use CoffeeScript, you kind of had to go all in all at once. With TypeScript, you want to get to where you have like lots of static types, but we understand that that's hard to do, especially on existing code bases. And so TypeScript is set up so if you want to convert an existing code base, you can just do it a little bit at a time here and there. And so kind of the way this works under the hood is there is actually another type in TypeScript, and that is called any. And the any type basically means it acts like a regular variable in JavaScript today, and that you can change the type as you go. OK, so I mentioned inferable types. So what do I mean by that? So in TypeScript, everything is statically typed. It has a type. But the TypeScript compiler is actually really, really smart these days, and it will try to figure out the type for you. So this is a simple example, but if you do const x equals 10, well, TypeScript will look at that like, oh, 10 is a number. We know it's a number. If you do type of 10 inside of JavaScript, you get number back. Like, this is a known thing. And so TypeScript will sort of convert that to this following statement below, where we're like, OK, 10's a number, therefore x is a number. And this is really handy because it means you don't have to spend a lot of time writing all these superfluous types. This actually works very similar to the auto keyword in C++. If you've used C++ 11, it's similar to the var keyword in C#. And if I remember right, I think Java has something too. I actually haven't been keeping up with Java, so I don't know for certain. But yeah, so this is actually really handy. And in practice, I actually only write types, or I give specific type designations in TypeScript when I know that TypeScript itself can't figure it out on its own, which is actually not very often, as it turns out. All right, so how do we use TypeScript with Node? How do we actually use this? How do we create a build pipeline and all that kind of good stuff? Like I mentioned, TypeScript is a compiled to JavaScript language. So the way you use it is really, really similar to how you would use Babel or Webpack if you're not using with Babel and tools like that. So there is an npm package. It's called TypeScript. You can install that globally, just npm install g TypeScript. You could also install it locally and use it from npm run scripts, the same way you use the Babel executable. And then the next step, there's this a little bit of special sauce here, which I'll talk about a little bit more in a bit, where we install this package called @types/node. And basically what that's doing is it's saying that, OK, this is going to be a Node.js app, so make all the Node.js things available, like process and all the modules, as opposed to saying this is a browser app, so make all of the browser types available. And then once we have those two things in place, we compile our files using the tsc command. That is part of the TypeScript package. We give it an outdir. I'd like to call it this, and then we just give it a root file index.ts. Now, cool thing about this is because TypeScript has all this type information and it understands modules and things like that, it will actually crawl your dependency tree. So if index.ts depends on a couple of other files, it will actually compile those too, because TypeScript understands the dependency hierarchy in an application. Now, there's a lot more configuration you can do than just outdir. And so just like Babel, there is also a configuration. You can specify all this in a configuration file. We call this tsconfig.json. And this is a very minimal sample of what that looks like. In this case, we are saying what we want the output module format to look like. In Node, Node uses CommonJS, so you just always set this to CommonJS in Node. If you're using this in the browser, though, you could also set this to require.js or system, which basically means ES6 modules. And there's a couple other variants that you can do. You can give it an outdir. You can say, I want to enable source maps. There's ways to say how you want your source maps embedded. You can give it a compilation target. So you can have it compile back to ES5, so it's compatible with ES5. Or you can compile straight to ES6, which basically just removes the type annotations. Kind of just whatever you prefer to do. Most people like to lint their code, and there is a linter for TypeScript as well, and we call it tslint. If you've used ESLint before, tslint is very, very similar. They even share a lot of the same rules, in fact. So you install the tool, you run it against your files, and you get your linting. Also, there is a tslint.json configuration file that's a lot like the eslint.rc file. Now, there are a couple of ES6 and ES7 considerations to keep in mind when using TypeScript. The biggest one is that TypeScript does not ship with a runtime. This was a design decision by the team. that they didn't want to go down that path. This is a different decision than what Babel did. So what do I mean by a runtime with that is, well, so TypeScript, it's a compiler. It will convert code at compile time. And then after that, it's kind of up to you what you do with that code. Most of the time, you just won't even notice that this is happening, but there is a couple of edge cases where you can kind of get into trouble with this. And that has to do with any sort of ES6 or ES7 runtime additions. So this is a thing like object.assign. This is an actual function that you can call and it executes code and does stuff. Symbol is actually a function as well. And there's a bunch of other functions that are defined in ES6. So TypeScript doesn't provide support for those. Now, in Node, this is usually not a big deal because you know the version of Node you're targeting and you know if those features are supported or not. But this does become a bigger deal in the browser where you have to do feature detection and all that. So typically the way that we recommend to do this is you can have TypeScript target ES6 as an output format, and then you can run it through Babel to get to ES5, and then you can also choose to include the Babel runtime, which has polyfills for all of this stuff. We have really good editor integration out of the box. Both Visual Studio and Visual Studio Code provides support. No surprise there. Also, like the WebStorm, PyCharm, IntelliJ, that whole family of editors from JetBrains, they all support it out of the box. And then most of the others, they support TypeScript with a plugin. So Sublime, Atom, Vim, Emacs. Just basically wherever you are, whatever editor you prefer to use, you can get support for TypeScript syntax checking. Now there's another question you might have thought of, and that is, what do you do about non-TypeScript modules? If you're writing a Node application, you're going to be relying on a lot of modules from NPM. And most of these were not written in TypeScript. So what do you do about type checking there? Well, we thought of that too. So we have this concept called a TypeScript definition file. And what a TypeScript definition file does is it creates a statically typed interface for this dynamic JavaScript code, and specifically for external JavaScript code. So once again, going back to C++, if you've ever worked with header files, these are very, very similar to that. And basically what these do is they have a declaration. They say, these are all the properties available, these are all the methods, this is the name of the module, this is what's exported. But there's no actual implementation, it's just the definition. And all of these files have a .d.ts extension. The extension is a bit of a magic extension. This is something the TypeScript compiler understands and will automatically go and try and fetch if it sees a JS file with the same name. This is really important for making this process really seamless, especially where you're requiring like a JavaScript file or something, and you don't want to have to do any special wrangling in your code to say, oh, and there's a definition file for that. You want it to just work. So it kind of does. And so this is kind of an example of what it looks like. Here we're creating a module called Planet. And so whenever you do require Planet, this is sort of like aligning that. And inside of this, we say we've got a couple of methods and an interface that are all exported. We're using the export keyword just like you would use in an ES6 module, where you do export, function foo. Now, creating those for all of your modules is going to be annoying. If you've ever actually looked at your Node modules dependency tree, you realize there's hundreds, if not thousands, of modules. So creating that by hand is not tenable. And so for that, we have this concept of global type definition files. Basically, these are all crowdsourced definition files that people created for all of the major modules in the ecosystem. And they exist in NPM under the types scope. So if you remember earlier, I said we're going to do this npm install save dev at types/node. So what that is the global type definition file for the Node runtime itself. But we have entries for a bunch of other stuff too. So if you're using like Express or Johnny 5 or CLport or whatever, there are actually type definition files for you in NPM. And so sort of like the best practice on this is whenever you install a module that you want to use, you always install two modules. One is the module itself. You do npm install save express. And then you do npm install save dev types at express, which looks just like this. And then whenever you import Express into your TypeScript, you have all of your type definitions right there, as well as all of your type checking and type safety, and all of those things that you love throughout TypeScript. And so this is really just scratching the surface. There's a whole bunch of stuff in TypeScript, and a lot of really fancy things you can do. So you can learn more about it at typescriptlang.org. And thank you very much. Time for questions? Okay.
I noticed in your samples you were, for interfaces, you called it like an I person, which is a little bit of Hungarian notation.
It is.
Actual best practice? Is that something you do for slides? Is that?
It's something that's used in all of the TypeScript documentation. It is kind of a best practice, mostly because a lot of times, well, I don't know if I say a lot of times, but it is fairly common that you'll have a class and an interface that basically have the same name, but you can't have two variables with the same name, so you have to differentiate somehow. So people do the I person. Honestly, I think it's mostly just a carryover from C#, and I've just kind of picked it up. But you definitely do not have to do that.
So let's say I install a package and then the types definition, like add type / whatever package. I update the package to a new version. It's a breaking change. I don't update the types package, or I don't update like the types in my npm package JSON. What happens?
Yeah, so okay, that's a more interesting one. I'll go and repeat the question on that one. So let's say you install, we'll say version 3 of Express, and you're using version 3 of Express in your app, or let's say you were like 2 years ago, whenever that was the current thing, and then you upgrade to Express 4. So that's a breaking change, and like the signatures of some of the methods actually changed. So how does this work in TypeScript? Well, it does kind of depend on the definition file. So in the case of Express, I don't think we had Express 3 definitions. But with any kind of modern thing, there'll actually be a sort of like linked up breaking change in the version of the definition file as well. So these definition files are in NPM, and so they're versioned. So like whenever you install the latest version of the Node TypeScript definition file, you're actually installing, well, I don't know if version 8 is out yet, but I know that there's version 7 you can install that has the version 7 type definitions for Node 7, and there's also a 6 and so on and so forth.
I was just going to say that those the type definition files, they usually come with like the packages that you install. Some of the bigger ones at least include them.
Mm-hmm.
So when I was, just the other day, I was working with the Amazon SDK. And so they actually have the d.ts file, so you can actually take a look and they got all their methods and you can see like what their types are and they actually specify it for you. So you can end up there, and especially in Visual Studio Code, you're like command click it and you like end up there. You can
Yeah, so there is another feature in TypeScript. This is not as common yet, but in your package JSON, there's actually, you can add a types field, and this will basically point to a type definition file. So like if your module itself is written in TypeScript, you don't actually have to do this separate @types package. It's like literally just a part of your package, and like the TypeScript compiler will read it. I think that's what you're referring to, correct?
I think so.
Okay. Yeah.
I just know that I ended up there like very oddly, like using the Amazon SDK. I was like, oh wow, this is kind of cool, because it took me like to a TS file, and I was like, wow, interesting. Like,
yeah, so like in Visual Studio Code, and I think some of the other editors as well, because we have all of these like stack definitions, we also know where code comes from. So if you have like an object that's being used in one file, you can usually go like right-click, go to definition. That's what we call in Visual Studio Code. It'll jump to the other file where that object or that class is actually declared. And it's like super handy for going back and forth in code. It's really awesome.
and it supports control minus, so you can go back to where you were.
Yep, yeah.
So kind of double checking for Express, then with the external type headers, you can have a type safe server.
Yep.
With callback mechanisms all being protected.
Yes, that's correct. Yeah. So like as long as you're using modules that have these definition files, you get complete type safety throughout your entire application. And so like, you're writing your Express app. Let's say you do, at your app.listen, or actually let's say on your app.get, you do app.get, whatever your route is, and you give it a callback. Like you can actually in Visual Studio Code hover over the error, rec, and res parameters, and you'll actually right there you'll see the types for those, which is really handy.
And also for variable arguments, same safety works.
So this is a more interesting one. So we're talking about variadic functions, functions that take different numbers of parameters, or they have like different signatures. This is a really interesting case in that like JavaScript does not have function overloading. This is something that usually only the static languages have. And so what I mean by this is there's one function, but you can call it in 2 or 3 different ways. In C#, C++, and Java, you actually define 3 different functions with the exact same name. JavaScript, you can't do that. Like there's this concept just doesn't exist in JavaScript. And so TypeScript has a bit of a hybrid solution to this. I can show you code after if you want to see details on this, but basically you end up writing all the definitions of the different types that you want for your function signature, and then you come up with this like master signature that encompasses all of the other signatures. But it can be done. It's a little clunky, but it's, given the constraints of JavaScript, it's actually, I think, pretty good.
So it's kind of a union.
Yes, it's a union. I'll go with you in the back. Yes, yeah.
So static languages like Java and C# let you, like try catch lets you catch specific types, like exception types. Is that something that TypeScript lets you do?
Yeah, so repeating the question, in other languages, you can do try catch. You can have multiple catch blocks. And you can say, I want to catch an arguments error, or it's been a while since I've done Java, so I'm forgetting all my error types. But you can say, I want to catch this specific type of error or this specific type of error. And you can have multiple blocks. So TypeScript does not have that concept right now. If I remember correctly, I could be wrong, but if I remember correctly, that is actually being discussed. But I'm not actually completely certain on that, though.
So I have a question about like distribution of TypeScript packages. Let's say I write a TypeScript package, but somebody else like wants to use it and they're writing in JavaScript, so they can't actually import my TypeScript code. But then like somebody else might actually want the TypeScript code, right? Do I like give them, like what do I publish on NPM for that, for like them to be able to install it and use in both TypeScript and in JavaScript?
Yeah, so you want to publish your module, and you want TypeScript authors to be able to use it in TypeScript, and you want your JavaScript authors to be able to use it in JavaScript. So I kind of talked about like how you can get your TypeScript authors to be able to use it already. You can publish something to the @types like scope, or you can also include it in your package JSON. For your regular JavaScript users, you have to understand the compiler a little bit, but it turns out it's actually the exact same thing you do if you're using Babel to compile ES6 modules to regular JavaScript. The way it resolves and the way it exposes things is actually the same. So let's say you export a class foo, that gets converted to module.exports.foo. And so in your regular JavaScript code, you would go, require my module.foo, and you get access to that class foo from TypeScript. All right, so last question.
Does a TypeScript class compile to an ES6 class or like an ES5 like prototypal kind of pseudo class?
All right, so yeah, the question is, what do TypeScript classes compile to? And the answer is it actually depends. In TypeScript, you can set your compilation target. So if you're saying, I'm going to target ES5, it will get compiled down to like functions and saying, foo.prototype.myMethod equals function, whatever. And so it'll break that out. It does it very similar to the way Babel does it. There's a little bit of like sort of supporting runtime code that's inserted at the top of the file, if I remember correctly. And so yeah, so it breaks that down, and it's actually true ES5 compliant code. Now, if you target ES6 as the output, then it will actually compile down to an ES6 class. All right, and that's all the time we have. So once again, thank you very much.